Observability and SRE Part 21. This episode has 15 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Today interview July 6, 2026. Environment availability. How would you manage availability across dev, QA, and prod environments? Here's a strong way to approach it. Availability should match environment criticality. Prod gets multi-zone or multi-region design, autoscaling, backups, slows, alerting, DR drills, and strict change windows. QA should be stable enough to validate releases but can usually use reduced capacity. Dev can tolerate lower availability and scheduled shutdowns for cost. The key is not making all environments equally expensive. It is making non-prod representative enough to catch issues before prod while preserving prod-grade resilience where users depend on it. Nice. Let's continue. Question 2. Today interview July 6, 2026. Safe promotion. How would you promote infrastructure and application changes safely between environments? Here's a strong way to approach it. Promote the same tested artifact or module version from dev to QA to prod instead of rebuilding at each stage. Use CI checks, Terraform plan review, policy as code, automated tests, smoke tests, approvals, and progressive deployment. For infrastructure, pin module versions and promote version bumps through environment directories. For applications, use immutable image tags, canary or blue-green rollout, health checks, slow gates, and clear rollback criteria. Great. Moving on. Question 3. Today interview July 6, 2026. Symptom versus cause alerts. Explain symptom-based versus cause-based alerts. Here's a strong way to approach it. Symptom-based alerts fire on user visible impact, error rate, latency, failed transactions, unavailability, or stale data. Cause-based alerts fire on possible reasons, CPU high, pod restart, disk pressure, certificate near expiry, queue backlog, or database log contention. Symptom alerts are better for paging because they tell you users are affected. Cause alerts are useful for ticketing, dashboards, or diagnostics, but too many cause alerts can create noise if they do not correlate with real impact. Alright, next question. Question 4. Today interview July 6, 2026. Noisy alerts. How do you reduce noisy alerts? Here's a strong way to approach it. Inventory alerts. Remove duplicates. Map each alert to an owner, runbook, severity, and user impact, and disable alerts that are not actionable. Convert raw resource threshold pages into slow or symptom-based alerts where possible. Tune thresholds with historical data. Add for or duration windows. Group related alerts. Route low severity issues to tickets. And use inhibition so one root incident does not page 10 times. After incidents, review whether alerts were early, late, missing, or noisy. Let's keep going. Question 5. Today interview July 6, 2026. Telemetry collection. What telemetry do you collect for a production Kubernetes platform? Here's a strong way to approach it. Collect metrics, logs, traces, events, and audit signals. Metrics include golden signals, pod or container CPU and memory, restarts, saturation, node pressure, HPA or autoscalar behavior, API server health, ingress or load balancer metrics, database and queue health. Logs should be structured with service, environment, version, request ID, trace ID, and error fields. Traces should cover critical request paths. Also collect Kubernetes events, deployment or change events, cloud audit logs, security findings, and business metrics for user journeys. On to the next one. Question 6. Today interview July 6, 2026. Trace ID. Why should every request carry a trace ID? Here's a strong way to approach it. A trace ID gives one request a stable identity across many services, pods, queues, and databases. Without it, debugging a distributed failure becomes guesswork across timestamps and partial logs. With it, you can see the full path, latency per hop, failed dependency, retries, and logs related to the same user request. It also improves incident response because engineers can move from a customer complaint to the exact backend path quickly. Good. Here's another one. Question 7. Today interview July 6, 2026. Structured JSON logging. Explain structured JSON logging. Here's a strong way to approach it. Structured JSON logging means each log line is a JSON object with consistent fields instead of a free text sentence. For example, timestamp, severity, service, environment, version, trace ID, request ID, user ID, root, status code, latency ms, and error type. This makes logs searchable, aggregatable, and machine processable in tools like cloud logging, Elasticsearch, Loki, or Splunk. It also helps alerting and incident analysis because you can query fields reliably instead of parsing text with brittle rejects. Nice. Let's continue. Question 8. Today interview July 6, 2026. Terraform module separation. Design Terraform module separation for networking, IAM, GKE, databases, and observability. Here's a strong way to approach it. Separate reusable modules from environment live code. Build small modules around ownership boundaries, network or VPC or subnets or firewall or NAT, IAM or service accounts or bindings, GKE or cluster or node pools, database or cloud SQL or AlloyDB, observability or log syncs or alerts or dashboards. Keep modules generic and versioned, with clear inputs or outputs. In live environments, compose these modules with separate state where blast radius differs. Avoid one giant module that hides risky changes or forces unrelated resources to be planned and applied together. Great. Moving on. Question 9. Today interview July 6, 2026. Distributed tracing design. Design distributed tracing for a request flowing through multiple Kubernetes services. Here's a strong way to approach it. Instrument the ingress or API gateway and every service with OpenTelemetry. Generate or accept W3C separant at the edge. Propagate it on HTTP or gRPC calls, and copy it into message attributes for async queues. Each service creates spans around inbound request handling, downstream calls, database queries, cache calls, and important business operations. Export spans through an OpenTelemetry collector with consistent resource attributes like service name, deployment environment, version, namespace, and cluster. Use sampling carefully so errors and high latency requests are retained. Alright, next question. Question 10. Today interview July 6, 2026. Rollback strategy. Design a rollback strategy for application and infrastructure changes. Here's a strong way to approach it. For applications, use immutable image versions, canary or blue-green deployment, health checks, slow gates, and automated rollback when error rate or latency crosses thresholds. Keep database migrations backward compatible so old and new versions can run during rollback. For infrastructure, keep versioned Terraform modules, reviewed plan files, small blast radius states, and a documented restore path from previous state or git commit. Always define rollback triggers, owner, command or runbook, validation checks, and communication plan before a risky change. Let's keep going. Question 11. Today interview July 6, 2026. Feature flag deployment. Design a feature flag deployment strategy for production releases. Here's a strong way to approach it. Separate deploy from release. Deploy code dark with the flag off. Enable it first for internal users or a small tenant cohort, then ramp by percentage or segment while watching business and technical metrics. Flags need ownership, expiry dates, audit logs, default safe behavior, and kill switches that work without redeploying. For critical paths, design flags to fail closed or fail to the old path, and include flag state in logs and traces so incidents can identify whether a request used the new behavior. On to the next one. Question 12. Today interview July 6, 2026. Customer issue scenario. Customers report production issues but dashboards are inconclusive. What do you do first? Here's a strong way to approach it. Start by confirming and scoping impact. Who is affected? What user journey? When it started? Regions or tenants or versions? And error examples. Check recent changes. Synthetic checks. Support tickets. Logs by correlation ID. Ingress or load balancer metrics. Dependency health. And business KPIs. If impact is real, open an incident. Assign roles. Communicate early. and choose a mitigation based on evidence. Do not wait for a perfect dashboard. Use customer examples to drive log and trace investigation. Good. Here's another one. Question 13. Today interview July 6, 2026. Failing request across services. A request is failing across multiple Kubernetes services. How would you trace and debug it? Here's a strong way to approach it. Start from one failing request ID or trace ID. Follow the distributed trace to find the first failing or slow span. Then inspect structured logs for that trace across services. Check ingress status codes, service endpoints, pod readiness, Kubernetes events, recent deploys, config changes, network policies, and dependency health. If tracing is missing, reproduce with a generated correlation ID and follow logs hop by hop. Once mitigated, add instrumentation for the blind spot that slowed debugging. Nice. Let's continue. Question 14. Today interview July 6, 2026. Alert fatigue scenario. Alerts are noisy and engineers ignore them. How would you fix the alerting system? Here's a strong way to approach it. Treat it as reliability debt. Export the alert list. Group by owner or severity or frequency. Identify top noisy alerts, and ask whether each one is actionable, customer impacting, and tied to a runbook. Delete or downgrade non-actionable alerts. Group correlated alerts. Add durations. Tune thresholds with historical data, and shift paging to slow burn or user impact alerts. Add an alert review process after every incident and a rule that every page must have an owner, runbook, and expected action. Great. Moving on. Question 15. Today interview July 6, 2026. Similar scenario AWS IAM mapping. During AWS to GCP migration, how would you map IAM roles, service accounts, and secrets safely? Here's a strong way to approach it. Inventory IAM roles, policies, users, instance profiles, and secret usage in AWS. Map workload identities to GCP service accounts with least privilege IAM roles, avoiding one broad shared account. Replace static keys with workload identity federation, or managed service identities where possible. Move secrets to secret manager with rotation and access logging. Validate access using test workloads and audit logs before cutover, and remove legacy AWS permissions only after GCP access is proven. Alright, next question. That wraps up this episode. Nice work practicing, and see you in the next one.